Let's head to NASA Langley Research Center in Hampton, Virginia, and meet up with some George Washington University graduate students. They are using pictures from the Mars Global Surveyor and geometry to survey Mars.
How are shadows measured on Mars?
How is geometry used to determine the height of land formation on Mars?
Hey guys, I want you to meet Corey Hernandez and Brooke Anderson. They're graduate students at George Washington University. Guys, what are you studying over there?
Well, with simple geometry and shadows, we're able to determine the elevation on Mars' surface, such as a mountain, Olympus Mons, that's 3 times the size of Mount Everest, or valley, Valles Marineris, which is the size of the United States.
Wow, those are some pretty large land formations. So, let me get this right. What you're telling me is that geometry is used to determine the elevation of land formations on Mars?
Yes, and we set up an example here for you to demonstrate this. If this is a mountain on the surface of Mars, this is a protractor to measure the angle of the sun. This is a metric ruler to measure the length of a shadow. If this flashlight represents the sun, we know that, like here on Earth, the sun is directly overhead at 90 degrees at high noon. Okay. And as the day goes on, it goes down to 0 degrees at sunset.
So, Corey, what you're telling me is this model here creates a right triangle.
The bottom leg can be represented by the length of the shadow, which we can get from taking a picture with the Mars Global Surveyor. Now, the sun makes an angle between the hypotenuse and the bottom leg. So let's pretend it's mid-afternoon on Mars. The sun would be at about an angle of 45 degrees, which, Brooke, how long is our shadow?
It gives us about 17 centimeters.
Oh, wow, so you got your angle there.
Yes. So, using our formula, remembering the tangent of 45 degrees is equal to 1, which we can find from our scientific calculators or our tangent tables, we can find the height of our mountain to be 17 centimeters. So, to double check our answer, we can see that the height of our mountain is 17 centimeters.
That's about what you calculated. That's pretty cool, Corey.
Well, I looked at Mars through the telescope, and it is definitely red. But could green slime have once existed on the red planet? That's one of the many reasons NASA Ames Research Center in Moffett Field, California is studying Mars. So now let's join researcher Chris McKay with the latest on green slime.
I'm interested in Mars, and in particular life on Mars. We know that early in Mars history it had water, lots of water. We can see the rivers and lakes that were formed by that water. The question is, when it had water, did it have life? To understand how life might have survived on a cold planet like Mars and where to look for it, we go to places on Earth where life is surviving in very cold, dry conditions, Mars-like conditions. This is a rock from the Antarctic, the dry valleys of Antarctica, the most Mars-like place on Earth. In this rock, there's life, but it's hidden inside the rock. Just below the surface, there's a layer of green. And these are algae and lichen, and they're growing inside the rock because the rock provides them a source of moisture while at the same time allowing enough light to come through. By studying life forms in these environments, we learn about the strategies that life can use in a cold, dry place. And we might apply those strategies to the search for life on Mars. And maybe we'll find evidence that there was life there when Mars was not too much colder than the dry valleys of Antarctica.
Well, looks like the sun has shifted, and that's about all we have time for today.
But before we go, Jennifer and I would love to hear from you with your comments and ideas. So why don't you drop us a line at NASA Connect, NASA, LARC MS 400, Hampton, Virginia 23681. Or if you're on the web, email us at connect@edu.larc.nasa.gov.